resolved. This video has been prepared for educational purposes only. No part of it may be reproduced or copied without the permission of the copyright holder.
Hello friends, I, Shreyans Kothari, welcome you all to the YouTube channel of S. Chand Academy. In this channel, we usually provide you video solutions of the published books so that these videos complement the book. You just need to scan the QR code and yes, you are there. We are trying to make that old saying true, किताबें भी बोलती हैं. Generally, we follow a simple pattern to all these videos. We just make you understand the simple concept or the basic concept behind the topic. And then we try to solve some of the questions from the book. This video can be seen standalone also because this video in itself is complete to clear the doubts. Talking about this book, man, this is the Quantitative Aptitude by S. Chand. One of the best books you can find for this particular section in the country. Why so? Because I guess this is the most comprehensive book available as it is regularly updated. The new questions are added and you name an exam, you will find this book appropriate. Why so? It is for bank, SSC, railways, MBAs, hotel management, sub-inspectors, UPSC, you name it and it is there. So for quantitative aptitude, even for the campus recruitments, students follow this book. And I guess this is the most comprehensive book of all and I guess the oldest one. Why I am saying oldest one? Oldest one with the updated one. So you don't have to go anywhere else, just stick to this book. So without wasting time, let's move to the chapter. So we have moved on to chapter number 30, that is Permutations and Combinations. I think that is the chapter, man. What I think is many students think that they are not good at that. Seriously, students, what I tell is this is one of the easiest chapters you can do. You just need to understand the basic concept of permutation and combination. What exactly permutation is, what exactly combination is, number one. Number two, where should we apply what? Because students generally get confused between permutation and combination and factorial. So I'll try to make the concept simpler. And then what we'll do is some of the questions on screen so that in any exam, if you get these type of questions, you do it very well. So let's move on to the basic concept, right? What I have tried is just put on the concept which is given in the book itself. I have got the screenshot of that so that you get it what exactly is written in the book. And then I will try to make it easy, right? So the first thing written was factorial n. So the best representation of factorial n is like this or like this. If you say this is what exactly this is n factorial, this is n factorial, and the n factorial is like when you multiply n into n minus 1. What is n minus 1? The number before this number into n minus 2 till what? Till when we get into 1. So whatever the number is, just multiply to its previous number, to its previous number, to its previous number till you get to 1. So for example, if anybody says what is 5 factorial, that means 5 factorial. Both are the representation of factorial. We just do one thing. 5 into n minus 1 is 4 into 3 into 2 into 1. This is 5 factorial. So when you multiply 2 into 3, 3 into 4, 4 into 5. So 4 into 5 is 20 and 3 into 2 is 6 into 20 is 120, right? So in the similar fashion, it is like 4 factorial, 5 factorial. Any factorial you can do is just multiply that number to its previous number, to its previous number, to its previous number till you get to 1. So this is the factorial. So I don't think that will be a big challenge for you to understand. There is one thing, 0 factorial. You just define 0 factorial is equal to 1 and 1 factorial is also 1. So 0 factorial and 1 factorial is 1. You can't say 0 factorial is 0 because you need to do at 1. So 0 factorial is always 1 and 1 factorial is obviously 1 because 1 till 1 is only 1, right? So this is basically factorial. Now we move on to the next concept which is given in the book, that is permutation. What exactly is permutation, right? Permutation is different arrangements of a given number of things by taking some or all at a time is known as permutation. Permutation is basically the number of ways to arrange things, some at a time or all at a time. For example, there are n number of books, so you need to arrange them in different ways. So how many ways will be there so that you can arrange it in all the different ways? It is known as permutation. So basically, when you arrange anything, when you take all of them or some of them, it is known as permutation. So I'm sure you are very much clear that when you arrange things, it is permutation, right? Say for example, there are some examples also. All permutation or arrangements made with the letters A, B, C. You have 3 letters A, B, C. And how many ways you can write all these A, B, C in different ways? So what we'll do is, we'll take 2 at a time. So they don't have to take all at a time. They just want to take 2 at a time. So what will you do? You will arrange them like AB, then BA, reverse of that, AC, then CA, then BC or CB. So total 6 arrangements are there when you arrange the 3 letters 2 at a time, and how many different ways you can do? So 6 ways, right? All permutation made with the letters ABC by taking 3 at a time. So if we take all 3 at a time, so how many ways they are? ABC, then ACB, then BAC, then BCA, then CAB, CBA. What is done here is, we took A first, then BC and CB. We took B first, then AC and CA. Then we took C first, then AB and BA. So in this way, you need to find out in how many ways you can put things all at a time or some at a time. Now, number of permutation, we need to go with the formula as well, because see, these are just 3, all taking all at a time or 2 at a time. That we can do with the writing all the possible ways. Say for example, there are 10 and you have to take 8 at a time. Then I don't think you will be able to do all the possible permutations with your hand. So there must be some formula. Let's see what formula is. So number of permutation of n things. So total number of things are n. Taking r at a time is given by. So if you want to take r at a time, say for example, we had 3 numbers, we wanted to take 2 at a time, right? In the similar way, there are 3 items and we want to take 3 at a time. So total things are n and we want to take r at a time, right? So what we do? We write like n p r, total number of items taken r at a time. Just one time we will take only r of them. So NPR is known as n into n minus 1, n minus 2, n minus r plus 1. It will go till n minus r plus 1. What is that? Okay, say for example, I need to find out 7p3 for example. So a very simple way to remember what to do. You have to go for 7 and multiples of 7 till 7 into 6 into 5 into 4 into 3 into 1. But only 3 digits. So only 3 digits means 7 into 6 into 5. That's it. Not much. Very simple idea, very simple way to connect is, you have to write the multiples of 7 to its previous number, to its previous number, to its previous number. Till how many digits? Only 3 digits. So 7 into 6 into 5. So 7 into 6 into 5 is 210. That's it, right? Say there are examples. So 8p2. 8p2 means 8 into multiples of 8 to its previous number, to its previous number, to its previous number, till 2 digits. So 2 digits is 8 into 7. So 8 into 7 is 56. Here it is. And there is 7p3. So here it is 210. So remember just one thing. Whatever n, p, r is given, you just need to go n till r digits. N till r digits, you need to multiply from it there. And there is a better formula for this. And remember this formula for sure. What you do is n factorial, then n minus r factorial. So what will happen is n minus r, and it will go till n minus r, and it will cancel out. That is the simplest way you can do. So n factorial divided by n minus r factorial. And if there are n objects, see, this is a different thing. If there are n objects, say for example total objects are n, in which p1 are alike of one kind, p2 are alike of another kind, p3 are alike of third kind, and so on till pr are alike of the rth kind, such that p1 plus p2 plus pr is n, because they are totally obviously different. So then the number of permutations, right? What exactly it is saying, that for example, you need to see A, B, A, C, C, A. Say for example, now you need to do arrangements. You can see that, see, all these A are very much like, and all these C are same. So in that arrangement, you will put this C or this C will remain same. So what we do is, see, there are 1, 2, 3. So A are 3, and B is 1, and C are 2. So what does it say? It says that whatever is same like, P1 are alike of same. So there are 3 of one kind, 2 of one kind, and 1 is one kind. So what you need to do is, how many total number of n are there? 1, 2, 3, 4, 5, 6. So 6 factorial. Divide by how many are like? So 3 factorial, and then 2 are same. So 2 factorial. So whatever the arrangement will be like this, because the total factorial of n divided by this, and that is known as number of permutation. So permutation is when there are similar type of things are there. What you need to do is just divide by that number of factorial. So if you want to solve this, this will be 6 into 5 into 4 into 3 factorial, divide by 3 factorial into 2 factorial. So 3 factorial gets 3 factorial cancelled, 2 gets 2. So 6 into 5, 30 into 2, 60 permutations are there. And what you can do is, you can write 3 into 5 into 4 into 3 into 2 into 1. And that 3 into 2 into 1 is again 3 factorial. So I did till that last one, right? So this is the permutation part. Permutation is how many types of arrangements are there, number of ways that you can arrange certain things, right? We move on to next part, that is combination. So combination is totally different from permutation, right? What exactly combination is? Each of the different groups or selections, remember this word, selections, which can be formed by taking some or all at a time, is known as combination. See, selection is different from arrangement. Arrangement is you need to put them in a proper order. Selection is you have to take them out, right? Say for example, out of the 3 boys, we want to select 2. So we need to select 2. We can select AB, BC and CA. See, how is it different from permutation is also clear from the fact that, see, AB is equal to BA. If you select AB and if you select BA, they are same. So in general way, combination will be lesser than the permutation. Why? Because when they are standing in an arrangement, AB is different from BA. But when you select them, you take them out, then they both are same. So in the previous slide, you saw that AB and BA were different different arrangements, but when you take them in the combination part, they are same, right? So know that AB, okay, it is written over there here only that AB and BA represent the same combination. So when you do that combination, you just put that combination part, right? The only combination of 3-person ABC all at a time is ABC. Whether it is ABC, BAC, CAB, CBA, all are same, right? And various group of 2 out of 4-person, various group of 2 out of 4-person from ABCD is AB, AC, AD, BC, BD, CD. That's it. So these are the number of ways you can select 2 people out of the 4 people, right? Important note that AB and BA are 2 different permutations but not combinations. That I told you that AB and BA are totally different permutations but not the combinations, right? But they represent the same combination. Okay, we move on to the formula. What is the formula? So it is like number of all combination of n things taken r at a time. So if you take r at a time, right? So NCR, you call it NCR is equal to how many? How much? So what you do is n factorial divide by r factorial and then n minus r factorial. N divide by r factorial divide by n minus r factorial. That is the way. In permutation, we had n factorial divided by n minus r factorial. And you divide that by r factorial, you get combination. So we can say that NPR is equal to NCR if you divide NPR divide by r factorial, because that NPR is similar to n factorial upon n minus r factorial. If you remember, there was a formula NPR is equal to n factorial divided by n minus r factorial. When you divide by r factorial, it will be NCR, right? So this is the way. NCN, if there is n over there and n over there, so what you do is n factorial divide by n factorial divide by n minus r factorial. So n minus n is 0, 0 factorial is 1. So n factorial by n factorial, the value will be 1. Why? As I told you, NCN, so it is n factorial divide by n factorial and then n minus n is 0 factorial, 0 factorial is 1 factorial, 1, and n factorial by n factorial is 1. So NCN is always 1. Remember that NCN is 1. Why? Because if you take all at a time, because n means all at a time, it will be only one combination as it is written. That the only combination of 3 letters ABC taken all at a time will be ABC. So if you take them all at a time, that means you have taken just once. So NCN will be 1 only. And NC0 is also 1. So there are some examples we'll do. This again is one of the good formula you need to remember, that NCR is equal to NCN minus R. Why it is like that? Because you have to anyways multiply by both R and N minus R. So you put it like this way or that way. They're both the same thing. So NCR is equal to NCN minus R. Say for example, I tell you 7C3. So 7C3 is equal to 7C4. Because why? 7C4 is what? 7 minus 3 is 4. So 7C3 is equal to 734. If both the bottom are add up to n, then they are equal, right? Okay. So we move on to questions now. Let's see how many questions we can do. But I am sure that the concept I shared with you all must be very much clear. Arrangements means permutation, selections means combination, and simple formulas you need to apply. Okay, so question number 1. Let's see what does it say. Find the number of ways in which 10 different flowers can be strung together to make a garland in such a way that 3 particular flowers are always together. See, 3 particular flowers are always together. So, if there are, say for example, total 10 flowers, in 10 flowers, right, we have 10 factorial of different ways, You can put all the flowers in a particular row, row. If there is a circular combination, just remember what I say. If there is a circular arrangement, just remember, if there is circular arrangement, it is always n minus 1 factorial. Remember this formula, कि if there is a circular arrangement, there will be n minus 1 factorial. So what I'll do is, see, we have total of 10 different flowers, in which 7 must be different in the different ways and 3 must be kept together. So I put that 3 as a one part because we need to club that 3 together. So 3 together and 7 differently. So how many are total? We will consider that is a single unit and that 7. So 7 plus 1 is equal to 8. So we have total 8 different things. 7 totally different, and 8th one, the last one, is 7, the bunch of these 3 flowers together, right? So we call it at 8 factorial, right? But if it is a circular, because it is a garland is a वो माला जो आप किसी को पहनाते हैं, so it is always in a circular arrangement. If there is a circular arrangement, we go with n minus 1 factorial. So 8 minus 1, we have 7 factorial as the answer, right? 7 factorial. But one thing you need to understand, that in those three types of flowers, you have clubbed them together. You need to remember that they also can be arranged in different ways. If there are 3 and those 3 are not in a circular manner, they are just ABC, then we have BCA, then we have CBA, then CAB, such type these, right? So these 3 flowers which are put together can be arranged in 3 factorial ways. So the final answer is 7 factorial into 3 factorial. You need to remember that totally there are 8 different types. Why? Because 7 are totally different and 3 are clubbed together. So it becomes 1. So 7 plus 1 is 8. Now if it is a circular arrangement, the formula is simple, like 8 minus 1 factorial, that is 7 factorial. So we put 7 factorial here. 7 factorial into 3 factorial. Why? Because 3 can be arranged in different ways. So 7 factorial is 5040 and 3 factorial is 3 into 2. That means 6. So when you multiply 6 into 0, 0. 6 into 4 is 24. 6 into 5 is 30. So 30240. Here we go. We got the answer. So you need to remember what exactly I have said. I have told in a very simple manner. What you can do is do just one thing. Just rewind if you don't understand, and you will get to know why there is 7 factorial and not the 8 factorial, right? We move on to another question. 7 books are to be arranged in such a way that 2 particular books are always at first and last position. So 7 books are there. 1, 2, 3, 4, 5, 6, 7. One book and one book. 2 particular books are fixed here. Say for example, I put one here and one here. So in the between, there are 5 books, and 5 books to be arranged in a particular manner. The simplest formula is 5 factorial, right? So 5 factorial is the answer. But stop. One thing you need to remember, that these books can be different. 2 different books. So 2 different ways. So 5 factorial into 2 factorial if you say, or there are just 2. So just multiply by 2, because 2 factorial is 2 into 1. These can be arranged in 2 ways. So 2. So 5 factorial is 120. And when we multiply by 2, it becomes 240. Is there any option like 240? Here we go. Just previous year question, December 2020, not a very old question like math question. Now I think you are near to my answers. Now you are understanding the concept very easily, because you just need to remember one thing. Is it an arrangement or a selection? First thing. And if it is arrangement, then how it can be arranged. What I did was I just put that in front of you. Okay, let's move on. Snap 2018 question. How many? See, this question and these type of questions are more frequent in any exam. These type of questions. How many different words can be formed with the word custom with a condition that the word should start with M? So custom, there are total 1, 2, 3, 4, 5, 6 letters, right? Custom, C-U-S-T-O-M. It must be started with M. So the remaining letters are C-U-S-T-O. All are different. So 5 different letters put in 5 different ways. So how many ways are there? Simple. That is 5 factorial, not the 4 factorial, right? A 6 factorial. So 5 factorial is 5 factorial. 5 factorial is, we know, 5 factorial is 120. So answer is 120. That is 5 into 4 into 3 into 2 into 1. So this is the way you need to do. And these type of questions are very much frequent in exams, whether it is banking exam or MBA exam, CDS exam. Let's do some more questions. This is CMAT. In MBAs, it is generally there, the permutation and combination. So it in CMAT 2020, not a very old, just recent question, right? In how many ways a committee consisting of 5 men and 6 women can be formed from 8 men and 10 women? See, there are total 10 women and there are total 8 men. Out of 10 women, you need to select, not arrange, select women. Women is 6 women and men are 5, right? So taking 6 women out of 10, you remember 10 C6, and taking 5 out of 8 will be like 8 C5. Yes, it is. Now you need to form the committee. So these many multiplied by these many will be the total, because they are like not or, they are just and. These and these are there. So just multiply all of them. See, 10C6, if you remember, it was 10 factorial. Divide by 6 factorial and 4 factorial. Why? N factorial. Divide by R factorial. And N minus R, that is 10 minus 6 is 4 factorial. Multiplied by 8 factorial. Divide by 5 factorial. 3 factorial. Because 8 divided by R factorial, N minus R factorial. So let's see how can be that can be made as simple. So 10 factorial is 10 into 9 into 8 into 7 into 6 factorial, because 6 into 3, 4, 5 into 4 into 3 into 2 into 1 can be written as 6 factorial. Divide by 6 factorial into 4 into 3 into 2 multiplied by 8 factorial, 8 into 7 into 6 into 5 factorial, divide by 5 factorial into 3 into 2 into 1. If you write 1, it's okay. If you don't write it, it's okay. So 6 divided by 6, cancel out. 4 into 2 is 8, cancel out. 3 is like 3. Done. So here there is no denominator at all. Now in this one, 5 divided by 5, done. 3 into 2 is 6, done. So what is remaining now with us? Here we have 7 into 3, 21, into 10, into 8 into 7, 56. That is the final answer if we have. So what we'll do is 56 into 21. 5621. Simply multiply 5 and 6, and then there is 112. 6, 5 and 2, 7, 1, 1 and 0. So 11760. Why 0? Because of the 10. So 11760. Is there any option like 11760? Beware that it is 670, it is 760, and we had 760, not 670. So final answer is 11760. And I don't think it was a big tough trouble. It was just easy. You need to find out how many from how many. That's it. And multiply them. That's it. Okay. And these type of questions also come regularly in exams, right? We move on to the next question. It was IIPM Rohtak 2020. Let's see what does it say. How many ways 7 tennis players can be seated in a circular order? As I told you, in a circular order, the simplest way is to n minus 1 factorial. So 7 minus 1 is 6. 6 factorial is the answer. So 6 factorial is 720t. So 720. If you remember, very simple. Just remember till 10 so that you don't get stuck anywhere. Okay. Move on to the next question. How many 3-digit even numbers can be formed using the digits of 1, 2, 3, 4, 5? See, I'll make it very simple for you. 1, 2 and 3. 3-digit number we have to find. And for this number to be even, I just want this digit to be even. Any number to be even can only be formed if the last digit is even. So how many even numbers are there? 2 and 4. So what I'll do is I can put here only 2 or 4, nothing else. If we have one number from these 5 here, one number from these here, we will have 4 type of combination, 4 type of numbers can be here and 3 different numbers here. So one number here, say for example 4, we get 4 out of the number 4 out of that. So will remain 1, 2, 3 and 5. So we can put all the 4s. So 4 different ways here and 3 different ways here. Just multiply 3 into 4, that is 12. And 2 and 4, there are 2 numbers. So 2 numbers, that means 2 different types. So 12 into 2, that is 24. So finally we get 24 and here it is. So very simple. You fix one number here, that is 2 or 4, that means 2 factorial, and remaining on the other numbers. So you make it easy. Let's move on to another question. A cricket team. I think that will be a good question. IBPS PO pre. That is, if it is PO pre, it must be a good question. A cricket team of 11 players is to be formed from 20 players, including 6 bowlers and 3 wicket keepers. The number of ways in which team can be formed having exactly 4 bowlers and 2 wicket keepers. See, out of 20, 6 are bowlers and 3 are wicket keepers, right? And from the bowlers, we need exactly 4 and we need exactly 2 wicket keepers. So in how many ways you can do? You can do it 6 C4 and 3 C2. Why? Because from the 3 you need 2. Now remaining, see, there are 20 players, 29 will be out of that. So remaining 11 are batsmen or all-rounder or whatever, right? And 4 and 2 are 6. So out of 11, you have took 6. You have taken 6. So remaining is out of 5. 5 out of 11 you need to take. So that is 11C5. Right? So it is not permutation, it is just combination. So we took 3. Now these can be a different arrangement because any of these can multiplied by any of these can multiplied by this is actually what exactly the answer is. So just simplify this. That is it. You don't need to panic. Very simple question, what I think. I have cleared the concept that how many out of how many, how many out of how many, and how many out of how many. There are three types like bowlers and wicket keepers and the other players, right? So 6C4, if you remember, 6 into 5 into 4 factorial divide by 4 factorial into 2 factorial. Why so? If you remember, it will be a 6 factorial. It will be 4 factorial and 6 minus 4, 2 factorial, right? In the similar way, 3C2. So it is like 3 into 2 factorial divide by 2 factorial and 1 factorial. So 1, leave it. 11 into 10 into 9 into 8 into 7 into 6 into 5 factorial divide by 5 factorial into 11 minus 5. 11 minus 5 is 6. So we got 6 factorial. So what I'll do is 5 factorial cancel. 2 factorial cancel. 4 factorial cancel. So 2 and it got 3. So here we got 3 into 5, 15. Here we got 3, that is 45. Now here, so 6 factorial can be written as 6 into 5 into 4 into 3 into 2 into 1. So 6 gone. Leave 5. What is 4? That is 2. 3, that is 3. So I am putting just 5 into 2 here. So here it is 10. Here it is 11 into 10 into 3 into 2. That is 6 into 7. Right? Finally, I know that I can remove the 10 also. But 6 into 7, 42. So 42 into 11. Just cut that 10. So that we have 11 here and then 6 into 7, 42 here. So just we have to simplify this and that will be our answer. Okay. So 15 into 3 is 45 and 42 into 11. Very simple way I do 42 and 42. So we get 2, 4 into 6, 4 here. So 462. So what I need is simple 462 into 45. Just do that calculation and we are done. So if we are 462, we have 45. So 5 into 2, 10, 1, 5 into 6, 30, 1, 3, 5 into 4, 23. There goes 0. 4 into 2, 8, 4 into 6, 24, 2, 4 into 4, 16, 17, 18. So we have 18 here. So final answer is, we got 0 here, we got 9 here, we got 7 here, we got 20 here. So 2790. So 20790. Is there any option like 20790? Is there? Yes, there is. So do a simple calculation, do simplification and you are there. Just do calculation very easily. These type of questions come in exam. That is it. We move on to next question. We have Bank PO question 2012 and I guess now that the questions will be of similar types. In how many different ways can the letters of capital be arranged so that the vowels always come together? See how many vowels are there? We have A and I and A. So we have C, P, T, L remaining and then A, I, A clubbed together, right? So CPTL is 4 and that one is 5. We have total different 5 letters. So 5 letter is 5 factorial. Now divide by this, multiplied by this. This is 3 and out of the 3, 2 are same. So into 3 factorial divide by 2 factorial. Why 2 factorial? Because 2 are same. So if I need to arrange these 3 in different ways, so what I'll do is I'll put the number of factorials and divide by the which are alike. If you remember how many are alike, just divide by that. So simplify this. Here we go. 5 into 4 into 3 into 2, 3 into 2 into 3 into 2 divide by 2. So 2 and 2 gone. Here we go. 5 into 4 is 20, 20 into 2 40, 40 into 3 120, 120 into 3. So 123 into 3 is 360. Is there any option like 360? Here we go. Simple question, simple answer. We are done. Okay, so let's move on to next question. Again, similar type of question. Okay, see, in how many different ways can be letters of the word extra be arranged so that the vowels are never together. Never together. So it is different question altogether. One is like always together, one is never together. So there is something different. And I have tried to pick the questions so that you can understand the different concept. So in this way, if in extra there are vowels never together, we do one thing. We'll find the total number of combinations, arrangements, and what we'll do is we will find in how many ways they will be together. So total arrangements minus together arrangement is never together. If you can understand one thing, we will find total arrangement. So if there are total arrangement is, say for example, X. In how many ways we can arrange them by putting the vowels together, we'll find that. So total arrangement minus the arrangement that are possible with putting together, that will give the answer when they are never together. So in how many ways extra can be put together? In total ways, 1, 2, 3, 4, 5, all are different. If they are all different, the total value is 5 factorial because there are 5. So it is 120, right? So answer must be less than that. So for sure 120 and 168 are not the answer, for sure. If we put these two together, right? So E and A together and remaining XTR is together. So XTR, if you do it XTR, there are 3. So 3 plus 1, there are 4 arrangement. So 4 factorial into these two can be arranged like in 2 different ways. So into 2. So 4 into 3 into 2. 4 into 3 into 2. 4, 3, 12, 12, 2 is 24. 24 into 2, that is 48. So 48 is in how many ways you can put them together. So you want they are never together. So do one thing, 120 minus these arrangement. These are the arrangement when they are together. So these are the arrangement they are not together. So 120 minus 48 is 72. Here we go. We got the answer. That is it. Very simple way. You just need to understand the question, what exactly question is saying, and do a simple method. We move on to the next question. Bank PO 2009 question. In how many different ways can the letters of the word smart can be arranged? So smart, SMART, 1, 2, 3, 4, 5, all different. So it's very simple, I guess. 5 factorial is 120. Now if you search for 120, you don't get it, you get confused. But I think there is one option called none of these. So answer is none of these. That is it. So there are many ways an exam will confuse you. So one of the example is here. Okay, we move on to next question. In how many ways, different ways banana can be arranged? Now this is a very good word because in banana we have 1, 2, 3A and we have 2 N's, 3 A's and 2 N's. And how many total number of their words, letters? 1, 2, 3, 4, 5, 6. So 6 factorial divide by 3 factorial into 2 factorial. Because whatever the number of letters are alike, you just need to divide by that factorial. So 6 into 5 into 4 into 3 factorial divide by 3 factorial into 2. So 3 factorials gets cancelled out. 2 factorial is like 2. 6 into 5 is 30 into 2, 60. Only 60 ways. That is it. Not anything else. So final answer we have 60. Move on to another question. Bank PO 2009 question number 46. Okay, we have to find out what? 5 men and 3 women. A committee of 3 members is to be taken so that 1 woman and 2 men. So 1 woman. So 3C1 is 1 woman and 5C2 is another. How many men are there? So 3C1 is 3 factorial divided by 1 factorial is 1 and divided by 2 factorial. Why 2? Because 3C1 is equal to 3C2 into 5 factorial. So 5 into 4 into 3 factorial divide by 3 factorial 2 factorial. Why 3 into 2? because n C2 is n factorial divided by r factorial n minus r factorial. So 3 gets cancelled out here, 2 here. So here it is like 10 here, then only 3 here. So 10 into 3 is 30. Here we go. Why? Because 3 factorial is 3 into 2 factorial. 2 factorial gets cancelled out. Here we have 3. Here we have 10. 10 into 3 is 30. Right? Move on to another question. Okay, so there's something more. A very good question, I guess. A box contains 2 white, 3 black, 4 red. I must write it here. 2 white. We have 3 black and we have 4 red. Okay, so what is said? In how many ways 3 balls can be drawn from the box if at least 1 black ball is to be included? At least. So how to do the at least concept? At least 1 ball means 1 black and other 2 non-black, right? Then 2 black, 1 is non-black, and the last one is 3 all black. See, at least 1 means 1 is black, 2 are non-black. 2 are black, 1 is non-black, and 3 all of them are black. So in that 1 black out of 3, so the probability of taking it out, 3 black, so 3C1 into non-black. See, non-black, how many balls are there? 4 into 6. So 6C2 plus this combination. So we have 3C2 into 1 non-black, so 6C1 and 3C3, because we have to take out all the 3 from black only. So 3C1 is 3 factorial divided by 2 factorial plus because this plus this plus this, and this is like 3, sorry, this also I need to find out, 6C2. So 6 factorial divided by 2 factorial, 4 factorial plus 3C2 is 3 factorial divided by 2 factorial into 6 factorial divided by 5 factorial, because 6 into r, right? And then 3C3. So if we have to take all the 3 and all of them are black, so there's just one combination, because 3C3 NCN is always 1. Okay, so let's calculate this and we are to the answer. 6 factorial. 6 into 5 into 4 factorial divide by 4 factorial into 2 factorial. So 4 factorial gets cancelled out, 2 is like 3, right? Okay, here we go. 3 factorial by 2 factorial. So only 3, because 2 factorial will get cancelled out. Plus, so plus, here we go, plus 3 factorial by 2 factorial again 3 into 6 by 5. So 5 factorial gets cancelled out. We got 6 and plus 1. So 3 into 6 is 18 plus 1 is 19 plus here. So we have 5 into 3, 15. 15 into 3 is 45. So we have total combination like 45 plus 19. 45 plus 19 is 64. As option, we have 64 and that is our answer. As simple as that. That is question number 53. We got 64. And I did it with the simplest way possible. So I think there are questions and I guess simple type of question, similar type of question. We have done at least wala question, we have done all of them, some of them, number wala, committee wala, we have done all of them. Just do the last question and we are done. In how many different ways the letters of banking can be arranged in such a way that vowels always come together? So I guess how many vowels are there? A and I, only 2 vowels, they are together, and we have total 2 N's also. So do one thing, 2 vowels together, and then we have B and K and G, right? 1, 2, 3, 4, 5, 6, 7. 7 out of 5 are there, so 5 and 1, 6. That will be clubbed together and single letter will be counted and then 5. So we have 6 factorial here. Divide by this 2n, so 2 factorial into that can be arranged in 2 different ways. So 2. So 2 and 2 cancel, 6 factorial. So the answer is 6 factorial and 6 factorial is 720 and we are done. This is again a bank PO previous year question. So I have tried to do different type of questions with you, and I have tried that I should take the questions which are asked in the previous year question papers. So in this way, the permutation and combinations is done. I am very much sure that you are propagating these videos to all your friends, and you have also subscribed to this channel, because whenever a new video will come of any competition exam, because S-Chand is a very big publication, so we are updating our books very frequently. So if we update a new book, we'll put a video solution and you will get a notification. So I am sure that you have subscribed to this channel. Thank you and take care.